All right, for this section, chapter 5, section 4, we're going to take a look at some special triangles, some equilateral and isosceles triangles. As a reminder, isosceles triangles are triangles with two sides that are the same, and equilateral triangles are triangles that have all three sides exactly the same. Okay, now let's go ahead and talk about some what they refer to as the base angles theorem. Again, many of these theorems seem a little obvious, but we do have to articulate them so we understand exactly what we mean and what we don't mean, and that is this. If we have an angle, let's say, for example, angle B, this guy right here, this angle, this wedge here, is opened up to this amount, okay? And coming from the other direction from angle C, if this wedge here, if it's open to the same amount as this one, then its opposite side is going to be the same as the first opposite side as well, okay? So one more time, let's take a look at that. If this is 20 degrees and this is 20 degrees, and if 20 degrees makes a wide open space of, say, 7, then 20 degrees would also make a wide open side called 7. Okay. All right, let's take a look at some examples here from today's work. Let's find the x. Here it is. No, that's not what they're asking for. Now, how long is this side is what they're asking us? And as I was saying before, if this angle, I don't know what it is, but it's identified by being a single hash mark. But if angle B creates a length of 12, and this angle matches the same angle, that's what they're telling us by having this single hash curve mark hash, that means that this also opens up to a size 12. And that's our answer. Now, let's do it again. It gets a little more complicated, as you know, as you might suspect. Let's take a look at this example here. Find the values of x and y. Well, let's consider BDC. That's this small triangle here in a BDC. This triangle is basically, all right, 180 minus 40, which is this one here. Okay, that means this angle right here is 140. Also, DBC, DBC, and DCB, they must be the same. Now, how would I know that? Because the opposite sides are the same. See how they're the same? We just did that over here. If two angles create two similar sized legs, but now we're going reverse. If they're two similar sized legs, then they came from the same size angle. So that's already here. The hash mark's already here. And that means these two are the same, meaning that combined, okay, these two angles, 2x, is equal to 40. Okay, that's what it means. And that shows us that x is actually 20. Now, one more time, since triangle ABC, the big one, is 180, you could take 180 minus 90, and we already know how big this one is, 20. So that's 20. That's 90. What's this guy right here? Must be 70. All right, let's take a look at this. All right, these don't take very long, okay? And they're not very mind-bending, okay? They're pretty basic logic, all right? And that's why we want to keep practicing here. Now, let's pretend AE is congruent to DE. So this guy and this guy are the same. That means their angles that make this guy and this guy would be the same. So angle B, well, we're going to call it EBA and we're going to call this one ECD. All right. Now the next question is, what happens if AE and EB are the same? Let me erase that. The AE and EB, what if these are the same? Okay. What if those angles were the same? Okay. This one, the opposite is this guy, and this guy would be the opposite this way. That means EAB and EBA would be the same angle. Okay. These would have to be the same angle. EAB, that guy. Okay. EBA, that guy. Now let's go again. If angle D is congruent to CED, if this and this are the same, then that means these pieces are the same. That's EC and that is DC. One more time. Let's try that again. If EBC, that's this guy right here. If EBC is the same as ECB, then this one and this one are the same. EB, EC. All right, well, you're not going to get any better at it until you give it a shot. So go ahead and give it a shot. Let me know if you can do anything for you. Good luck.